All right, let's talk about algebra. But this isn't going to be your high school math class. We're going on a journey from 9th century Baghdad all the way to the phone that's probably in your pocket right now. And along the way, we're going to uncover this incredible hidden connection between an ancient mathematician and the very code that runs our modern world. But first, let's just get this out of the way. For a lot of us, the word algebra brings back, some not so great memories, confusing letters, difficult homework. But what if I told you that you already use algebra? Like, every single day, without even thinking about it. Okay, picture this. You need 6 notebooks for school. You look in your bag and you've already got 4. So how many more do you need? Your brain just did that instantly, right? It went 4 plus something equals 6. And that something, of course, is 2. That little intuitive leap you just made? Well, that's it. That is algebra. At its absolute core, algebra is just a tool we use to find an unknown by giving it a temporary name, a symbol, like x. That question mark in your head becomes a variable, and the problem becomes an equation. 4 plus x equals 6. You literally just solved for x. So if we all do this without even trying, what makes algebra this whole separate field of math? Well, it's because algebra gives us a formal language to talk about these unknowns. It takes us one giant step beyond just simple counting. And this really gets to a key difference. What we all learn first is arithmetic. In Arabic, it was called al-hisab. It's all about specific known numbers. 2 plus 2 is 4. End of story. But algebra, or al-jabr, is about a much bigger idea. It lets us describe the relationships between numbers even when we don't know what all the numbers are yet. So let's put an official pin in it. Algebra is the branch of math that uses symbols for unknown numbers so we can build equations and, this is the important part, find a systematic way to solve them. But where did that system even come from? To answer that, we've got to hop in a time machine. We're going back to the 9th century, to what was then the intellectual center of the world, Baghdad, and its legendary library, the House of Wisdom. And our story really zooms in on this one man, Muhammad ibn Musa al-Khwarizmi. He was a brilliant Persian scholar, an astronomer, and a mathematician at the House of Wisdom. And honestly, he was about to change the world. So around the year 820, he writes this absolutely revolutionary book. The title translates to The Compendious Book on Calculation by Completion and Balancing. And right there, in the middle of the title, is the magic word, algebra. This right here is the direct origins of our word algebra. Now, to be fair, people had been solving for unknowns for a long, long time. The ancient Babylonians had complex formulas. The Greek mathematician Diophantus was working on algebraic equations. But Al-Khwarizmi's contribution was a total game changer. He was the first to pull algebra out and treat it as its own unique discipline, with its own rules, separate from geometry and arithmetic. He created a system, and centuries later, when his book was finally translated into Latin, it basically lit the fuse for the mathematical renaissance in Europe. And his core idea is right there in the name. Al-Jabr literally means restoration or completion. It refers to this specific move, taking the negative term from one side of an equation and moving it to the other side to make it positive. It's the simple, elegant act of restoring balance to the equation. And that one rule is the foundation for solving for x. But Al-Khwarizmi's system wasn't just a method. It was like planting a seed. The ideas he laid out were so powerful that they grew into this huge, sprawling field with all these different branches, taking algebra way beyond simple equations and into the study of really complex structures. I mean, modern algebra has gone in some wild directions. There's linear algebra, which is basically the language behind all computer graphics and data science. And then you have something called abstract algebra, which is fascinating. It's not even about numbers anymore. It's about the deep-down rules and structures that govern entire systems. And you might think, oh, abstract structures, that sounds complicated. But they are literally everywhere. Take a Rubik's Cube. The complete set of every possible twist and turn you can make actually forms a perfect algebraic structure. It's called a group. Abstract algebra gives us the language to describe the fundamental rules of the puzzle itself. Which brings us to the final, and I think most mind-blowing part of this whole story. We're about to see how that 9th century scholar's name is secretly and powerfully running our 21st century world. I mean, let's be crystal clear. Algebra is essential. It's the language of business, of science, of all technology. It is the engine behind physics, chemistry, computer programming. I mean, from figuring out your budget to building a skyscraper, it is the basic framework we use to solve problems. But there is a much, much deeper connection hiding in plain sight. Let's go back to our scholar's name for a second. Al-Khwarizmi. Say it out loud. Al-Khwarizmi. Got it? Okay, hold on to that. And now, think about the absolute heart of all computer science. Those step-by-step sets of instructions that a computer follows to solve a problem. In Arabic, that concept is called Al-Khwarizmiyat. Are you hearing it? Al-Khwarizmi, algorithm. It's not a coincidence. The word algorithm, the very concept that powers every app, every website, every single piece of modern technology, is just the Latinized version of Al-Khwarizmi's name. It's a direct tribute to the systematic, step-by-step method he gave to the world almost 1,200 years ago. His name literally became the word for a process to solve a problem. And so the legacy of algebra isn't just about finding X on a blackboard. It's about building the logical frameworks, the algorithms that let us solve for the great unknowns of our own time. From a simple notebook problem to the incredibly complex code that's shaping our future, it all started with one beautifully simple idea: giving a name to what we don't yet know. The only real question left is, what are we going to